Hello, ladies and gentlemen. We need to talk about a couple of things really quickly. So here we're going to draw this little rectangle. The bottom is the base, the side is the height. And this formula only works for this shape, this rectangular shape. The formula we need to be aware of is this one. I is equal to BH cubed over 12. Okay? So it should be pretty apparent when you look at this that this number, height, since it's cubed, is going to make a tremendous difference to our moment of inertia. Another thing you need to know is that I is going to be equal to some number in inches to the fourth power, or quartic inches. What this is telling us is kind of like mass, except we're talking about something in rotation. So this shape has this inertial property, and that's what we're describing with the letter I. The next one we need to think about is, I'm going to make a little change. So in the notes you did, or in the notes from PLTW, they talk about delta max, and I'm going to use a lowercase d for deflection distance or displacement. So it's actually a measurement. So d is equal to the force applied at the center of the beam. So you should have something like this. We have a beam, we have a force being applied in the middle. It's being held up at 2 points, just like this. So we're pushing down right here. All right. So it's the force times the length, and the length is the space between these two supports. And that's also cubed. And then that's over 48 times E, the modulus of elasticity, times I. Okay. In the lab, we have collected, I'm going to highlight these. These are measurements we can get from the data. We can get this deflection distance. We can find the force applied. We know the length between the supports. 48 is a constant, and we can calculate this. So really the only thing we don't know is this modulus of elasticity. So we need to rearrange this formula to make it tell us the modulus of elasticity. So we're going to multiply both sides by E. We're going to divide both sides by D. So that means that the modulus of elasticity is F times the length cubed over 48 D times I. All right. Modulus of elasticity is represented by the letter E, and that's going to be in pounds per square inch. What this tells us, what modulus of elasticity tells us, it tells us about the stiffness. How easy is it, or how difficult is it to bend a material? So that's really what we're probably going to try to find in our lab and our analysis. In the next video, I will put together a how-to for finding all of this information using a spreadsheet. All right, I hope you find this helpful. Thank you.